Welcome to the session. I'm Rachel Blackburn. I'm on the corporate operations team at Oracle, and I'll be moderating the webinar today. This webinar is part of the Oracle at Oracle webinar series, where you'll have the opportunity to hear from the executive team that reimagined Oracle. In this series of webinars, we share insights from our own journey to the cloud and demonstrate how we're using Oracle Cloud to power our business and enable exceptional customer and employee experiences. And we'll share our learnings along the way so that others can hopefully do the same. And let's dive into today's topic. Over the course of the next couple of minutes, you'll hear how Oracle reimagined its global corporate data warehouse with Oracle Cloud. Now I'll hand it over to your webinar host for today, Kishan Agrawal, to introduce himself and tell you about what he does at Oracle.
Hey, thank you, Rachel. Hello, everyone. Welcome. I'm Kishan Agrawal, Vice President of Technology and Infrastructure in a group called Oracle Application Labs here at Oracle. I'm currently leading the effort to migrate all of our corporate applications and data warehouse infrastructure to cloud as part of our overall cloud transformation journey. In this session, I'm going to talk about how internally at Oracle, we reimagine our central global corporate data warehouse in Oracle Cloud Infrastructure. I'll cover our strategy, touch upon the high-level architecture, and I'll discuss about our migration approach, and then I'll finish with some of the lessons learned. And at the end, we'll have time for Q&As. Okay, let's dive in. Let's begin with a brief introduction about our group. Oracle Application Labs is the group responsible for implementing and managing all the business applications that runs Oracle, whether it's ERP, finance, HR, as well as all the data warehouse and analytics solutions used internally at Oracle. So in that sense, we are like one of the largest customers of Oracle, and we go through the same experience, same set of challenges that many of our customers would go through. We are part of the larger product engineering organization, and we have a direct feedback loop with all of our product teams. And finally, in sessions like this, we share our internal best practices and lessons learned with our customers. Our vision, the group for our group, is to be 100% cloud-only IT organization and run all of our enterprise applications, the data warehouse, and all other enterprise workload in Oracle Cloud Infrastructure. Now, for migrating to cloud, instead of doing a big bang migration approach, we have adopted a coexistence model between our on-premise system as well as cloud as a step towards cloud. And it has been very successful. And one of the key ingredients for this success is the ability to use the same set of platform products to build solutions like Oracle Database or Analytics Cloud, as well as use the same set of tools to manage and operate systems both on-prem and in cloud. For example, we can use Oracle Enterprise Manager to manage both the cloud database as well as on-prem database. Now, let me begin with providing a high-level overview of our corporate data warehouse ecosystem. In Oracle, we have a very large central data warehouse, which supports both corporate reporting as well as it supports more than 30 business-owned or departmental data marts. It is used for both analytical reporting as well as operational reporting by almost all lines of business in Oracle. And also we use the EPM product for some of the financials and other reporting. So here, what you see in this slide is the overall ecosystem. At the bottom, we have all our data sources, like whether it is the legacy on-prem e-business suite applications or SaaS, the Fusion application. We have a lot of applications running in Oracle Cloud Infrastructure. Then business own many transactional system. Plus we get data from external third parties. So those are all our data sources. Then we use various replications and ETL tool like OCI data flow or Golden Gate or Oracle data integrator to replicate this data to our data warehouse. At the top, you see our reporting and visualizations layer where we use like Oracle Analytics Cloud or Data Visualization Cloud Service or Smart View, all these products to build those reports and dashboards and data science solutions on top of this warehouse. And this, as I said, this warehouse serves all of our business for operational reporting, analytical reporting. It supports 30, 40 business data marts. And finally, we also run some of the custom application on top of this warehouse. So this is kind of like a 40,000 view of our entire data warehouse ecosystem. Now, to give you a sense of the scale and size of this warehouse, we have around 20,000 unique users logging into this warehouse or analytics system every day, who run more than 5 million reports every month out of this data warehouse. And this results in almost 850 or 900 million queries. These are analytical queries run on this warehouse every day. And the data warehouse processes close to 100 billion rows a day. So it's a massive, it's a very large data warehouse or running on Oracle database. And it feeds data from all of our enterprise or corporate transactional application, whether it's in cloud or on-prem, as well as many departmental systems. And it provides that analytic solutions to all of our lines of business in Oracle. Now, before I jump into the details of the data warehouse architecture and migration, let me first talk about the cloud transformation journey that we are currently going through. Essentially, why we moved to Oracle Cloud. So as Oracle transformed itself as a product company to a service company, we also needed an analytics platform that would enable us to innovate faster and meet the changing needs of our business. So here I'm showing you a comparison of how we used to run when we were on-premise data center versus how our analytics system runs in our Oracle Cloud infrastructure. So earlier, where we were on-prem, we were constrained by these challenges. What do you see on the left? First is the capacity constraint. We'll have this yearly capital expenditure budget, which will set the budget for the entire year, and any changes would require a lot of planning and discussions and all. And at many times, we would be it would be very challenging to keep up with all the data growth and the compute required to support or manage the data warehouse, because it's not that every year we'll be able to move to the latest and greatest Exadata or the new infrastructure or the hardware. So we'll be still running like 2 or 3 generation older Exadata because we'll not be able to move to the new one immediately. There'll be slow pace of innovation, and then there'll be a longer cycle to deliver new features to our business and end users. Our entire analytics applications was a monolithic in design. So it would take, it's like a one big analytic application per pillar. So it would take longer time to make changes, as well as it will require a lot of coordination and testing before we could do a simple release or simple new feature release to our production system. Most of our provisioning, deployment, and patching and other processes were manual. So the maintenance was very high. And given that we were on either on older infrastructure or some of the legacy platform versions, many of our performance of our reports and ETLs would often miss the business SLA. The SLA that we would have agreed with the business, the system would miss those SLAs. But since we moved to Oracle Cloud Infrastructure, we saw these benefits. The first and foremost is the elasticity. The elasticity to scale up and scale out as needed. So if we need more capacity, if we need more, say, database storage or compute, we'll just subscribe more, or we move to or add to another quarter rack or full rack. So there is no upfront huge investment. We'll just buy as we need. We will always get the latest and advanced capabilities in cloud, say whether the new machine learning capabilities in autonomous database or advanced analytics or natural language processing or advanced visualizations in Oracle Analytics Cloud. It will be available to us now immediately. As soon as the product releases a new capability, it'll be available for us to build solution on top of that, rather waiting for months and quarters of upgrade cycle that we used to go when we were on-prem. We're also able to build our solutions more modular and flexible way, like we would have everything, all the analytics application design in a smaller chunk, and that will allow us to release this components or this feature faster. The pace of innovation increased considerably because in cloud, there are frequent releases of new features and capabilities, and we will be always on the latest version of, say, infrastructure or database, analytics cloud, or any other platform services that we want to use. And then with the Gen 2 cloud or Gen 2 of Oracle Cloud Infrastructure, the performance is much better. For some of our application, we are able to achieve even 4 nines uptime. That's like few minutes of outage every year. And then we have less or no outages for our system. So that's kind of gives a sense of like comparison of like running data warehouse on-prem versus running in Oracle Cloud Infrastructure. Now, as we decide to move our data warehouse to Oracle Cloud, instead of doing a simple lift and shift, we decided to completely reimagine our data warehouse based on the feedback and requirement and challenges that we had in on-prem. We came up with this like 4 basic architectural principles to build the new warehouse. The first should be modern and highly available data as a service concept. So we use all the latest technology and tools to build the modern data warehouse. We build high availability, not only in the infrastructure level, but in the data layer itself. For example, when we are, let's say, changing the transactional system, or we are loading the data, the reporting layer should be available all the time. There should not be any outage because we are doing some activities or maintenance in the other layer. And the data should be fresh or almost near real time all the time. Next, we wanted to adopt the continuous integration and continuous delivery principle and processes for the entire data warehouse and analytics solutions. As you know, it is relatively easy to implement CI/CD principles for transactional system, but it is challenging for data warehouse given the data volume, what testing you need to do, the comparison of data, and all those things. But we wanted to adopt the same principles in our data warehouse running in Oracle Cloud. So we adopted things like unit testing, automated deployment, doing dark launches where we will release, let's say, new ETL or new solutions which will be turned off, not be enabled right away. We'll just enable it when we need it. And we were able to do all this, adopt this CI/CD processes, given the features and capabilities provided by the core OCI infrastructure, as well as products like Oracle Analytics Cloud. Next fundamental principle was to adopt the microservice architecture. I don't mean like, everything is REST services and all. What I mean is, essentially, we should be able to deploy a change to any part of our warehouse, whether it is the ETL, whether it is the report, whether it is the, the star schema and all, without having any major impact to other part of the system. So we adopted things like, say, synonym switching or partition exchange load, or using, say, master keys, so that there is always reference to one set of keys. And then all these ETLs and replications and reports are designed as, one independent unit or independent apps, which could be managed, updated by a small set of developers. No more like hundreds of developers working in one code line, doing a big bang release every month or every quarter. All the work was divided into smaller chunks, smaller projects, which could be deployed automatically and more frequently without having to do like major coordination with a lot of other teams. And finally, we decided to do incremental migration to reduce the risk and impact to our business, so that business should be still able to run reports, get data and all those while we are going through the transitions. And also the transition, when they transition or cut over to the new system, it should be stable and it should be almost like a non-event. So these were like the four guiding principle or the core principle that we adopted in this new architecture. Now, to achieve this, one of the fundamental change that we adopted was this: we implemented this new 3-layer logical data architecture. Earlier, when we were on-prem, it was a little bit of all over the place, almost like a spaghetti architecture. There are a lot of data duplications. There are multiple duplicate keys, multiple versions of the same data and all. So we put together this new clear data layer architecture. This is a logical layering. It doesn't mean that everything is in Oracle database or one system. I'll cover that detail in the next slide. But here, what you see at the bottom is what we call the raw data layer. This is where we replicate raw and untransformed data from all of our sources, whether it's cloud or on-premise, and it provides data to the upper 2 layers. The primary purpose of this layer, or the goal, is to get the data from the sources as fast as possible. The middle layer is called the foundation data layer. This is where we build the confirmed dimensions, facts, and star schemas and all. And this is where we adopted standardized keys so that it will allow blending of data and this matrices across pillar, right? If you're referring to a customer dimensions, you should be able to use that in the finance pillar or HR pillar or everywhere else. And also it will allow blending or reusing of this data in various business data marts without having to copy or recopy that data. This layer is optimized for high performance data integrations, like all the ETLs and all those are run in this layer. So this is more optimized for that purpose. So the indexing strategy and all those things are done aligned with that. At the top layer is the access and performance layer. This is where all your reports, dashboards, and all visualization, they get data from here. Of course, if you're doing drill down and all, your dashboard can go to the next layer or the bottom layer, but primarily this top layer is optimized for that high performance reports and all. And here also we use those standard keys and matrix so that there is no data duplications if there are 2 teams or 2 pillars. If they're building reports, they don't have to recopy those data. And as I said, these are logical layers. So it's not necessarily, so part of it could be in Oracle Autonomous Data Warehouse, some part of it could be in object store or streaming or other services. So this is kind of the one of the bigger fundamental change that we did as we moved from our on-prem legacy data warehouse to the new data warehouse. Now, if I want to drill down a little bit more into the actual physical or the infrastructure level architecture. At the center, you see the Oracle Autonomous Database. This is where we build those two top layers, the foundation layer and access and performance layer. The raw data layer would span the autonomous data warehouse, as well as part of it will be in, say, object storage or the streaming service. For example, if there are, old data or very large, say, telemetry data, those kind of data, we would not bring that to, say, Oracle database. We'll put that in object store. At the top, you see various analytics or various cloud services that we use, analytics cloud and data visualization cloud to build the reports and dashboards and doing data discovery. We also use the data science service to build various data science solutions. Then on the left, you see, our data ingestion from cloud sources. So we again use various data integration services like OCI Data Flow or Oracle Data Integrator or Golden Gate to ingest data from cloud sources. Similarly, on the right, you see we use Oracle Data Integrator, ODI, or Golden Gate to ingest data from various on-premise sources. And this entire stack is running in Oracle Cloud Infrastructure. And in the top left, you see we also use compute and Java Cloud and other services to build other tools, like to build our CI/CD pipeline or deployment or to run our unit test and all. We use those other services to automate various processes. And I quickly wanted to share this. This is, some of you might have seen this diagram also in Oracle reference architecture web page. This is essentially a different view of the architecture or the data layers that I already covered. So if you see on the left, this is the data refinery. This is what we call the raw data layer, where we are ingesting data from various sources using various tools like Golden Gate or Data Integrator or Data Flow and all. And then we use Oracle Autonomous Data Warehouse or Object Store to build the foundations layer, where we build the aggregations and conform dimensions and all. And then on the right, we use Analytics Cloud and Oracle Machine Learning and other cloud services to build those applications and dashboards and all. So I just wanted to make sure, like, you understand it's kind of that's the architecture we follow internally, and that's the one we recommend to our customer to adopt as well. Next, I'm going to discuss our migration strategy to cloud. But I'll begin with the overall strategy that we use to migrate our on-prem systems, like whether it is analytics system or transactional system or any other workload. We came up with a framework that we use to migrate any workload. And then I'll cover specifics of what we followed for data warehouse. So we came up with this framework which takes into consideration both the business and IT aspect, and has been very successfully adopted by many groups in Oracle, by us, as well as, for example, our industry apps business unit also use this framework to move all of our industry cloud services to OCI. As you see, there are 4 stages in this framework: envision, architect, engineer, and launch. And as you migrate your workload, you can do everything in one cycle if you decide to do it like a big bang, or you can iterate through some of these phases if you're doing in stages. So now let's drill down to each of this stage or phase. First is envision. This is where you establish the vision for the cloud transformation and you align on the strategy with your key stakeholder. You, of course, need support from your executive management because embarking on this journey could impact your other corporate priorities. For us, the vision was to be 100% cloud only IT organization. And the vision was to transform all of our business processes, our business analytics and insights, and provide a delightful experiences to our user using both Oracle Cloud applications as well as all the infrastructure and analytics solution. So with our executive management support, we align this strategy with all of our business partners, and we align all the priorities and work streams and initiatives with this cloud transformation journey. Next, once the vision and strategy alignment is done, you start architecting the migration. There are two key activities here. First is the technical work to come up with the technical architecture to migrate and run your workload in cloud. Here you do like simple proof of concept to learn how to operate in cloud. You deploy simple application to understand various cloud technologies, various building blocks, like how Oracle data autonomous database works, what operation you need to do versus what cloud would do, how security works, how will you do the networking or internet connection to your data centers and all. So you migrate small systems and simple system to understand how to migrate as well as how to operate. So essentially you build the foundation in cloud. And the second, another key activity is to prepare your org for that change. Like identify and acquire skills that your resources will need to operate in cloud. You may have to define new change management process, like how will you deploy to cloud, how will you approve, how will you track changes, and also you probably have to come up with new support process, because say in Oracle autonomous database you don't have to do a lot of like day-to-day operation or support work, so you may have to change your process. So this is in architect stage, you do both. You do experiment with your technical part as well as you define your change process and change management. Once you're done with that architect stage, next you move to the engineer stage. This is where you develop and test your migration solution. You use various tools and utilities provided by Oracle to prepare your migration solution, and you migrate test systems using those solutions, and then you make adjustments and do refine and improve your solutions. Next, once everything is tested and ready, you move to the launch stage. And this is where you do the actual final cutover. You move your production systems, and then you focus on any post go live activities like stabilizations, improvement, and all. And once your production is stable, then you start leveraging new capabilities in cloud to continuously improve and build new solutions, adopt new technology in cloud. This is what we call like move and improve. First you move, and then you use all the cloud technology to improve your solution. And this would complete like one full cycle of migration framework. And if you adopted a phase migration, then you can iterate through some of these stages as you move the remaining system. So obviously you don't have to go through the full cycle again. For example, probably you'll have your envision and architect done. Once that is done, you'll iterate between engineer and launch stage based on type of your workload. For example, if you're moving say transactional system, then your engineering stage might be different than if you're moving a data warehouse and all. So you iterate between those stages. So this is like a common framework that, as I said earlier, we use to migrate all of our enterprise workload, whether it's the analytics system or proprietary applications or any other enterprise system. Next, I'll share the actual migration solution that we use to migrate our data warehouse to cloud. And we adopted that four-step migration approach to minimize the risk as well as to reduce any disruption to our business. The first is the experiment stage. This is where we build a new data warehouse in cloud. We call it Cloud Data Platform. Earlier in or CDP, earlier we used to call GCW, Global Corporate Warehouse. Now we call it CDP, Cloud Data Platform. So we put together all the building blocks, like we deployed various services like Oracle Analytics Cloud, Autonomous Database, data flow, data catalog, and all those things. And we integrated them together. We figured out like how the security would work, what kind of connectivity we'll need. So we, the authentication, the federation. So we build the environment or the system itself. Next, we went to the learn stage. This is where we design and deployed the new data layer architecture, the one that I covered earlier. So we deployed that data layer, three-layer data architecture to this new system, and we developed data replication solution. So before we move all the analytics solution, we started replicating a lot of our data from various data sources to this new system. And then we migrated or delivered some of the functional content for some of the simpler applications, which are not like cross-pillar. It is very independent and simple. We deploy those applications or those analytic applications to this new system because it then help us learn all this cloud technology. Next, we went to this build stage where we adopted a dual deployment strategy where we deployed all this new solution to both on-prem and cloud. I'll cover more detail on that in the next few slides, but we adopted that dual deployment strategy because it helped us make the transition easier. We also run, like as we deployed some of this application, this is when we did a lot of optimization. We worked through a lot of stabilization work because we'll be running system in parallel. Like, we still have the legacy application, legacy analytics solution running on-prem, and we have the new solutions or new content area already deployed to Oracle Cloud. So we'll have both things running in parallel, and it will give the technical team or the dev team to find any performance bottleneck issues and all, as well as it will help our business teams to evaluate both in terms of performance as well as content, and then they can switch to the new system. So it makes that transition almost like a non-event or easy to migrate. And finally, we go to the innovate or the final stage. And this is where we are today. We replicate all the remaining data sources from all of the remaining corporate systems, whether in cloud or on-prem. And then we migrate all the analytics apps and data to this new system. And finally, we'll sunset all our on-prem warehouse. We are not done with this step. We are still, we have moved a lot of our critical content, but we are in the final stages of moving the remaining. And then once we are done, we will then shut down the on-prem system. Now, as I said, we adopted that dual deployment strategy. So let me drill down further into that. So this is where we were at the beginning. This is our on-premise system. We have this global corporate warehouse running on-prem Exadata, and we have all of our on-prem data sources replicating data, and then we build analytic apps in this. As you see, there were no data layers or any of those things. It was pretty much like a spaghetti architecture. But it was because This system was built over like 10, 15 years. It was very rich, sophisticated, and very complex ecosystem because it was getting data from hundreds of different transactional systems, and it provided analytics solution to the across the board in the company to all of our lines of business. So we could not just take as is and move it to cloud. And also, as we move to cloud, we wanted to ensure there'll be no disruption to business. So we want to go to the new architecture, but the challenge was like, how do we get there? Like, uh, if we just shut down everything and start building the new solution, that will not be acceptable. So we have to be in this coexistence mode where we are still providing some incremental changes and enhancement to the existing solution while we are building the new solution. And then we transition to the new solution where, because end of the day, business still have to report, they need those reports and solutions to run business. So this is the approach we took, and this is really important on how we made this transition really smooth. So few things going on here. Let me walk through the details. On the left, you see the existing on-prem data warehouse. On the right, we have the new cloud data platform running in cloud. At the bottom, you have the data sources. So as I said in the beginning, we are in this cloud transformation journey, not just for the warehouse system, but we are also moving our transaction system to Oracle SaaS or other offering. So let's say we as you see in the bottom, we migrate some on-prem, say HR system or any of those systems to Oracle Cloud. Or if we have already moved a system to Oracle Cloud applications or SaaS offering, what we did is, because we align the move to the new cloud data warehouse in line with moving the transaction system to cloud. So as part of this move, or if we have already moved a system to Oracle SaaS, first thing we did is we built this replication app, which will replicate data from this Oracle Cloud application or SaaS or from cloud sources to both the on-prem warehouse as well as the new warehouse. In the new warehouse, you see that we have this, clearly defined 3-layer data architecture and all. We put those schema structure and some of those, high-level structure also in the legacy system. So we deployed this FDL, RDL, and FDL both in the legacy as well as new. So of course, there is this incremental cost in the on-prem for an interim period, but it makes the transition so much easier. So again, so we deployed this replication app to both new system as well as old system. So now the data is flowing to both. This allowed the existing analytics system running in the legacy corporate warehouse to consume this new data. Let's say we move the HR system from Oracle E-Business Suite to Oracle SCM Cloud. The existing analytics system, they need that HR data. We cannot just disrupt those things. So we replicate the new HR data from Oracle SCM Cloud to the legacy system, and this analytics app can then consume that, but they will consume in the new architecture way. They will consume from the raw data layer or FDL deployed to the legacy system. And in parallel, we'll build the net new analytics app completely using the new architecture in CDP or the cloud platform. Now, from a business perspective, they still have the legacy solution, but they also have the new solution running in parallel. So they can take time to compare, build that confidence that new solution works, the data is there, and it also meets all their business requirement and meets their challenges. Once they're comfortable and it meets all those SLA, they can just start using or switch to the new analytics app. So it almost makes the transition like a non-event or very smooth. It does not cause any disruptions or concerns and all. And we then repeat this process. We move one, and then we move the next. We move the CRM. We move the one by one. We move the remaining transaction system to cloud, as well as we move all the replication apps, as well as we build a new analytics app in the new platform. And then anything which will, this is where we are today, and anything which will still there in the legacy system for which we have not moved to cloud, rather than waiting for the long tail end of it, finally we'll just migrate the remaining application, like we'll replicate the data from the on-prem source directly to the new platform, the CDP platform, and migrate that last remaining few analytic apps to the new CDP platform, and then we shut down and decommission the on-prem system. So we went through this phase, which has been very successful. We have been going in this phase for the last few quarters, and we have been moving every quarter some of our pillar or functional pillar, and soon we'll be able to migrate or finish the remaining applications. And so far it did not cause any kind of disruptions or issues for our business. And this approach has been very successful. So I covered the high-level architecture, both at the physical layers as well as the data layer. And then I talked about how the migration approach that we took. Now, in the final section, I want to talk about some of the lessons that we learned along the way. The first and obvious one is, for us at least, is the phased migration approach worked better than Big Bang, because it minimizes the risk. It minimizes outages and disruption to business. And also it helped build that confidence with our business and stakeholders, right? So we move one application, they use it, they like it, it delivers much more than what they used to have in the legacy system. So it built that momentum, and we were able to move the remaining system to cloud. Second, the dual deployment strategy that I just covered made the transition almost like a smooth and non-event. We were, as I explained, we were able to do the technical go live before the actual business cut over. So we'll have the new system up and running in production, in cloud, and both IT team will be able to verify, test, do all the performance testing and all those things. And business user can also go and, based on resource and time, they can verify and all. And when they're confident and comfortable, they can switch. And also from a technical IT or development perspective, it helped us to start developing the new solutions sooner, rather than, so it gave us a head start, because we deployed this new 3-layer data architecture, all the schema and all those things in the existing on-prem system. So and also we replicated data from the cloud sources to the on-prem Exadata. So our developer, they started adopting the new architecture, new data structure and all, without having to wait until they move to the CDP or the new platform. So they started building new solution on-prem, and then because their code was getting deployed to both the system, they can just switch to the new system when they are ready. And finally, the shared partnership between IT and business is very crucial. I mean, of course, it is crucial for all such initiative, but particularly in this case, we collaborated on strategy. Few years back, we had detailed discussion with all our business partners to identify the challenges, the gaps in our legacy system, like how we used to have issues with data duplications and latency and governance problem and security and all. So we work very closely with them to come up with the strategy in terms of how the new solution should work, how the conform dimension should work. Because the business needs, when you're building a conform dimension or standard matrix, you need input from various lines of business, because that conform dimension or or standard matrix has to work across the pillars, right? So it requires a lot of those close partnership with all your business teams. And then of course, solution design and testing of the new solutions. All this, all these various phases, starting from the inceptions to the final production cutover, it has been a close partnership between IT and business. And once we are live, we are still, getting regular feedbacks and, enhancement requests from them. And we are building or improving the solution, leveraging all the latest and greatest technology in cloud. And other key aspect is data governance, because I covered a lot of this technical aspects and migration and all, but we also wanted to have data governance and data security, like who gets access to what data and all. We did technical implementation to control that, but business defined the governance model on those data security. So these are the three key lessons learned, which could be broadly applicable to many of our customers. So with that, that's all I wanted to cover in this session. I did not go into the details of, say, a particular capability in analytics cloud or data warehouse or, on autonomous database, because the purpose was to, give you an overview of what has been our strategy, what is our new architecture, and how we migrated to this new system in a very smooth and efficient way. With that, I thank everyone for joining, and then I'll now hand it back to Rachel for Q&A.
Thanks, Kishan. And for everybody, if you have questions, remember you can submit them through the Q&A function at the bottom of your screen if you haven't already. We'll start with a couple of questions for you, Kishan. First question, how do you implement departmental data marts in the new cloud architecture?
Sure, great question. So I think I mentioned in our corporate data warehouse, we support more than 30 departmental or business-owned data marts. So the strategy we have adopted is, instead of all these business teams building like satellite data warehouses, taking data from the corporate data warehouse and build it outside, and putting in a lot of redundant efforts, as well as duplicating a lot of data, we created the data marts within the same data warehouse. So there'll be like in the database or in the object store, there'll be storage area allocated, schema created, the grants and services given to the business team, so that they can build the data marts right on top of the same data warehouse. They can bring their own departmental data in their content area, but they will have direct access. They're like first-class citizen in the data warehouse itself. So rather than taking, let's say, enterprise or corporate data to another database or satellite warehouse, they sit directly on the data warehouse. So they have direct access to all this curated data, and they can build reports and all those things with joins and blending with those corporate data. So that's how that has been our strategy. Like rather than building this data mart separately, we provision them or support them directly in the corporate data warehouse itself.
Awesome. And could you provide some details on operational cost savings, if any?
Sure. So as I mentioned, we have been in this journey to migrate all of our enterprise systems, not just the data warehouse or analytics. We are moving all our transaction system and all other workloads. So there is overlap to what resources and compute were used for data warehouse versus transaction. And also, rather than giving a specific number for warehouse, I'll just say that in terms of overall saving per IT by moving to our cloud applications and cloud infrastructure, it's in millions. And the saving has been not just in terms of when we compare infrastructure costs, like, you buy a new Exadata on-prem and you upgrade, or you buy new hardware every few years versus you subscribe to cloud, whether it's Exadata cloud service or autonomous database or other platform services, if you compare those subscription costs as well as the resources needed to manage this system, like when we have this on-prem data warehouse or database in cloud, sorry, on-prem, you need dedicated DBAs and resources to manage those database. But by using, say, autonomous database or autonomous data warehouse, you do not need those dedicated resources because Oracle Cloud takes care of day-to-day operations and patching and upgrade and all those things. So you have those resources which you could use for other projects or other initiatives. So when we compare both in terms of the resource saving as well as cost of infrastructure and maintenance and all, the overall saving is in terms of millions.
Great. And could you talk a little bit more about using Oracle Analytics Cloud and how that improved reporting at Oracle?
Sure. So when we move our data warehouse to OCI or Oracle Cloud, all of our reporting, the front end dashboard, data visualizations, everything is done through Oracle Analytics Cloud. As you all probably know, it's a managed service. So first, there are a few benefits. First, we now build all of our reports, all the dashboards, everything we using Oracle Analytics Cloud. We no longer use the on-prem analytics server or OBI stack. We use Oracle Analytics Cloud service. First benefit, the biggest benefit is it has a lot of advanced capabilities in terms of machine learning, using natural language processing or faster performance, much more richer visualization capability. So there are all these capabilities which probably does not exist in our on-prem version or the version we are using, because we are still using some older version of OBI. And the second benefit has been that because it is a managed service, that means it is managed by Oracle, we don't need IT resources to manage those services and servers and all, and we can focus on building the solution, building the insights and solution for our business, rather than spending time on operational activities.
Great. Thanks, Kishan. Another question for you, slightly unrelated to this webinar, but would you be able to provide any insight on how we're using Apex?
Sure. So I think we use Apex for in few areas. Like, I think just a brief, I think many of you probably know Apex is a low-code development platform where you can build sophisticated applications very quickly. So we use Apex in multiple areas where we are building, say, custom applications, like, in-house application or internal application, which is used by Oracle inside for our employees or customer. We build sophisticated transactional apps using Apex. In the data warehouse context, we use Apex technology for two things. One is to build, again, some quick applications on top of data warehouse. Let's say we want to provide a UI for spreadsheet upload, spreadsheet download. Of course, you can do that in Oracle Analytics Cloud, but there are use cases where we wanted to build like simple application for data adjustments or updates and all. So we use Apex to build that. But Apex platform also provides another very, great technology called OATS, the Oracle REST Data Services, which makes it really easy to build REST services on top of your database. Say you want to expose your data or your API, your data or database views or queries as a REST services for other system to consume the data or send data. That OATS services helps build those services very quickly. So we use Apex and Oracle REST data services in warehouse, as well as to build many transactional apps.
Great, thank you. And I think we have time for one more question before we wrap up. Do you replicate data from all of the source systems as they are into our data warehouse, or do we replicate what's needed, I guess?
The strategy we have taken is we replicate everything, because we build that raw data layer. So we replicate everything. I mean, we have not, we are in that path to replicate everything, so that we have the complete representation of all of our transactional data available in our data lake or raw data layer, so that team can build analytics solutions very quickly, rather than going into, whenever they want to answer a new business questions, rather than figuring out, okay, where is this data, how do we get it, and all those things. All this data is already available in data warehouse. But having said that, the strategy we have also adopted is we build this turnkey replication. So let's say out of 10,000 tables from one of the sources, we'll replicate, let's say, the very critical or common one in the first go. And then as we need more tables, it is as simple as just adding those list of table to a configuration file, and it will start replicating. So it doesn't become like a big exercise or big project in itself to replicate new data set. But going back to the original question, our goal or strategy is to replicate almost all of the data from the sources.
Great. And this will actually be the last question. Can you share some detail about the underlying infrastructure used, for example, XSCS, and what else we're using in terms of infrastructure?
Sure. So when we for the database, we started with XSCS, Exa Cloud Service, but we moved to autonomous data warehouse, right? So from database, we use like a combination of XSCS and Oracle Autonomous Data Warehouse. For, as I said, for storage, additional storage for raw data layer or some historical data or bulk data extract and move, we use Oracle Object Store Cloud Service. We also use pure compute instances where we build, say, ETL solutions or CI/CD pipelines. So we use a lot of this pure compute, whether it's VM shape or bare metal shape. We use that for a lot of this, internal tools and those kind of work. And of course, we use for analytics solution at the top layer, we use Oracle Analytics Cloud, data catalog, and data science services.
Great. Well, unfortunately, that's all the time for questions that we have. So we'll go ahead and wrap up now. I want to thank everyone for joining. And if you could just stick around for an extra moment to let us know your thoughts and feedback, you'll see a poll come up on the screen. We'd love to know what you think. We're always trying to improve. And while you're here, I'll let you know that the webinar replay will be available within 48 hours, and you'll be able to find it on Oracle Video Hub. You'll also receive a follow-up email shortly after this webinar that will give you instructions on how to access the replay, as well as provide a PDF of the presentation for your reference. If you have any additional questions or would like to talk to someone about what you heard today, you can reach out to the email address that you see on the screen. It's oracle@oracle-contact_ww@oracle.com with your additional questions. And if you're an Oracle Cloud customer, remember you can always continue the conversation, and you can even talk to Kishan on Cloud Customer Connect. So with that, I'll give everyone a couple more seconds to answer the poll, but thank you so much for joining, and we hope to see you virtually on future Oracle at Oracle webinars. Thanks, Kishan.